Hello math learners! Do you know what is a rational number? Or do you know the different forms of a rational number? Perhaps you know how to convert rational numbers like fractions to decimal or decimals to fraction. If you do, then good for you. But if you don't, I suggest you watch this video until the end. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in ML with Sir Ash. This is still your free access math teacher Ash. And today, we're going to discuss the most essential learning competency-based lesson for Grade 7 Mathematics, Quarter 1, Week 4, which is all about rational numbers. The objectives of this lesson is to convert fractions to decimals or vice versa. Now, the first question is, what is a rational number? Well, a rational number, by definition, is a number in which it can be expressed into the form a over b, where a and b are both integers and b must not be equal to 0. Now, for us to understand really what is the meaning of that rational number, let's talk about a quick history of the numbers. If you were still in elementary, we have known that the numbers started from what we call the natural numbers. These natural numbers are also known as counting numbers. We have 1, 2, 3, 4, 5, 6, and so on and so forth. And the counterpart of that is 0. Okay. So, when the natural numbers and the 0 are combined together, they become what we call the whole numbers. The whole numbers are from 0, 1, 2, 3, 4, and so on and so forth. But the counterpart of a whole number is the negative numbers. Now, the negative numbers are those numbers located before 0, meaning those are negative 1, negative 2, negative 3, and so on and so forth. Now, if you want to group the whole numbers and the negative numbers, you will get the what we call integers. The integers, as we all discussed from the previous discussion, it is the combination of positive numbers, 1, 2, 3, 4, 5, 6, and so on and so forth, and the negative numbers, negative 1, negative 2, negative 3, and so on and so forth, as well as the neutral number, 0. Now, the counterpart of the integer is what we call the non-integer. The non-integer are most commonly well known as fractions and decimals. So those are the numbers with 5 over 2 or 0.25, 0.70. So those are examples of non-integers. Now, if you want to group the integers and the non-integers, then what you will get is the rational numbers. So, to make the long story short, rational numbers are all of these kinds of numbers. They are both the natural, the 0, the whole number, the negative numbers, the integers, and the non-integers. Now, let's go deeper to what is really a rational number. Okay, math learners, we have here a series of questions which is for us to classify which among these given numbers are rational numbers. So the question is, which of the following is a rational number? We have number 1, 3 over 2, number 2, 1.73205, and so on and so forth. Number 3 is 20, number 4 is 0.25, and number 5 is 0.44444. Okay, so it will not end with just 4. Okay, now, remember what I've said earlier during the definition that rational numbers are numbers that can be expressed into a over b, where a and b are both integers and b must not be equal to 0. Okay, now, technically, rational numbers are very popular as to be considered as a fraction. Okay, so which among these is a fraction? So this is the one. So this is considered already as a rational number. Okay, Now, let's go to number 2. Now, as we can see, this is 1.73205 dot dot dot, or this is an ellipsis. It means that it will not end, meaning it will continue. It will, this is not what we call the non-repeating, non-terminating decimals. Now, as what I've said earlier, that among the non-integers are the decimals and fractions. However, this is a special decimal because this is not considered to be a rational number because we cannot convert this into a fraction. Okay, because remember, if it is non-terminating, non-repeating decimal, then that is not a rational number. Okay. Number 3, we have a whole number, 20. Remember that a whole number is under a rational number because 20 can be expressed with over 1, which is just the same as two numbers expressed in A over B. Okay, so this is also a rational number. Now, we also have number 4, 0.25. Now, how can we know that 0.25 is a rational number? Now, you can convert 0.25 into a fraction. If you are successful, then it can be called as a rational number. Now, remember that 0.25 or 25 hundredths, to be read, okay, can be converted into 25 over 100. If you divide this or you get the lowest term of this, it will become 1/4. And if you convert 1/4 into a decimal, it will become 0.25. Therefore, 25 over 100, 1/4, and 0.25 are just the same. Basically, these are rational numbers. So, we can also say that 0.25 is also a rational number. Okay. And that is R. Okay. Now, let's go to the final number. We have 0.44444, or this is what we call the repeating but non-terminating. When we say non-terminating, it doesn't stop. But repeating because of this dash here, or what we call the vinculum, it means that it will repeat. So, 4444444. Okay. Now, the question is, how do we convert this one? Technically, 4 or 0.4444 can be converted into 4 over 9. Because 4 divided by 9, you will get 0.444444. And that is a fraction. And because of that, we can say that this is a rational number. Now, do not worry on how to convert this one because the next part of our discussion is all about conversion. Okay, math learners, we are now here in the part where we will convert fractions to decimal and decimal to fractions. Now, remember that a fraction that can be converted into that decimal, or a decimal that can be converted into a fraction, is a rational number. And remember also that rational numbers can be anything in which it can be a whole number, an integer, a non-integer such that it is a fraction or a decimal, and it can also be counting numbers. So, among those different forms of rational numbers, I hope you have a clear understanding of that. Now, let us talk about conversion. Okay, math learners, we are here with examples on how to convert fractions to decimal. Now, in converting fractions to decimal, the technique is very easy because what you will do is you just apply division, by which the numerator will become your dividend and your denominator will become your divisor. Now, most cases, it cannot be applicable. So what you will do is you will add index until such time that there will be no remainder. Okay, now let's start with 1/4. What you will do here is you just divide 1 by 4. Now, 1 divided by 4 cannot be, right? So you will add an index of 0. So, since you add a decimal here, you will put a decimal place there. Now, this is 10. 10 divided by 4, and that is 2. 2 times 4, that is 8. You subtract this one, the answer is 2. Now, you still have a remainder. Therefore, you will add another 0 for an index, and this will be brought down, becoming 20. 20 divided by 4, that is 5. 5 times 4, that is 20. And 20 minus 20, you don't have any remainder left. Therefore, for the decimal, you have 0.25 or 25 hundredths. Easy, right? Now, let us go to 3 over 5. Now, for 3 over 5, the same process. You divide 3 by 5. It cannot be, so you add an index. So, adding a decimal point here, you will also add a decimal point in your quotient. So, 30 divided by 5, that is 6. 6 times 5, that is 30. 30 minus 30, you don't have any remainder. So, therefore, your answer is 0.6 or 6 tenths. That's already the decimal equivalent of 3 over 5. Easy, right? Now, let us go to our question number 3. Question number 3, we have 5 over 7. So, what we will do is we divide 5 by 7. 5 cannot be divided by 7. So, we add an index of 0. So, we add a decimal point in our quotient. So, 50 divided by 7, that is 7. And 7 times 7 is 49. Now, subtracting this 50 and 49, we have 1. We still have a remainder, so we will add, okay? So, that is 10 divided by 7, that is 1. So, 1 times 7, that is 7. We have 3, right? So, we again bring down 0. We have here. So, 30 divided by 7, that is 4. 4 times 7, that is 28. We have 2, okay? So, we add again 0, bringing down another 0 here. So, 20 divided by 7, that is 2. Okay? 2 times 7, that is 14. So, we have here 6. Right? Okay. Bring down 0, another 0. So, 60 divided by 7, that is 8. 8 times 7, that is 56. We have 4. We bring down again, we add a 0 and then bring down. So, we have 40 divided by 7, and that is 5. So, 5 times 7, that is 35. And we have... Okay. So, as you can see, this is just the same here. The same scenario, right? So, this will become repeating, non-terminating. So, therefore, what we will do is we put a number there. It means that it will follow the same pattern. So, we have 0.714285, 714285, 712485, and so on and so forth. Meaning, that is just the same as 5 over 7. So, therefore, what is our final answer? You just have 714285 with a vinculum. Okay? Meaning, it will repeat the same numbers again. Okay? So, you just put a 0 here, and that will be your final answer. Sounds tricky, right? But that is the way it goes. Okay? Now, let us go to our question number 4. Okay, math learners, we are now in our fourth example, which is 1/3. So, we have 1 divided by 3. So, 1 cannot be divided by 3. So, therefore, we will add an index of 0. So, that is 10 divided by 3. That is 3. 3 times 3, that is 9. We have 1. Okay, the same concept here. So, if you continue this scenario, 3 times 3, that is again 9. And then we have 1, bring down again 0. So, this will never stop. This kind of scenario will never stop. So, therefore, you can just put 0.33 or 0.3 with a vinculum for your answer. Or 0.3 with a vinculum. Or 0.3333. Or you could just write 0.333. Okay? Sounds easy, right? Okay, now, let us go to conversion of decimals to fractions. Okay, math learners, we are here to our example for conversion of decimals to fractions. Now, this is 0.3, 0.75, 0.333, and 0.67. Okay, now, as you can see in our example, we have 0.3 and we have 0.333. This is what we call a terminating, because it ends with 0.3. This is what we call non-terminating. Okay, so you must know what is the difference between a decimal that doesn't end or a decimal that is just a fixed number. Okay, so what you will do here is very simple, my dear math learners. If you can read this number, that is 0.3 or 3/10 from the word itself, it says 3/10. It means that the place value of 3 here is in the 10th place. Okay, so therefore, this can be converted into 3/10. Easy, right? Okay. Now, since 3/10 is already in the lowest term, that is your final answer. Now, let us proceed. We have here 0.75. Now, 0.75 can also be read as 75 hundredths. So, basically, you just write 75 over it with hundreds. But, your answer doesn't end here. Why? Because 75 and 100 can still be converted into its lowest terms. Okay, so both are divisible by 25. So 75 divided by 25, that is 3. 100 divided by 25, that is 4. So your final answer is 3/4. Easy, right? Now let us go to an example in which it doesn't end. Okay, math learners, we have here example number 3, which is 0.33. This is an example of a decimal that is non-terminating and repeating, because this 3 here has a vinculum, meaning it will never stop. That is 0.3333. Now, the question is, how do we convert this one? Okay, first thing you should do is you will make an equation. Let's say that this number will be our first given. We have n is equal to 0.333. Okay, doesn't end, right? Okay, now, the next step you will do is you multiply it by 10. Okay, you multiply it by 10. So when you multiply this by 10, of course, you also multiply this by 10. Right? Okay, what will happen is it will become 10n, and this will also become 3.3333, and it will never end. Right? Okay, so you have now 10n is equal to 3.3333. Now, what you will do is you subtract the first given number to your 10n. So, what you will do is you connect your first equation. Okay? Your first equation, which is n is equal to 0.333. Okay? What you will do is you subtract this one. Okay? Now, if you subtract 10n by n, the answer is 9n, because n here, it means 1n, right? Okay, so we have here, if you subtract 3 by 0.3333, the answer here is 3. By solving the value of n, you will have an answer of 3/9, or 1/3. Meaning that the fraction that is equivalent to 0.3333 is 1/3. Here, 0.3 is 3/10, but 0.3333 is 1/3. Now, if you want to check this one, 1 divided by 3, and you will get 0.3333, which is just the same as our example earlier from the fractions to decimal. Sounds tricky, right? But for sure, by just practicing more, you will be good on this matter. Now, let us consider another example. Okay, math learners, for you to be good on that matter, let's say, let's change our fourth example. This is 0.67, right? Let's change this into 0.666, non-terminating. Okay? But repeating. Okay, so this will never end. That is 0.666. Okay, the question is, how do we do this? First step you do is you make an n, okay, and you make this as the given. So that is 0.6666, so on and so forth. Okay, right? The next thing you should do is you multiply it by 10. Okay. So you also multiply here by 10. The answer for that one will become 10n, 6.66666. Okay, now. Right? Okay. Next is you use your original equation and you subtract this. Okay? You subtract them. So that is 10n minus n, and that is 9n. Now, if you subtract the 0.666 here with the 0.666 there, you will have 6. By dividing both sides by 9, so n will become 6 over 9. But this can be simplified. You can get the lowest term of 6 over 9 into 2 over 3. So therefore, if you divide 2 by 3, you will get 0.6666666. Okay? I hope you get that kind of technique for non-terminating repeating decimals. Okay, now let us go deeper to our discussion. Okay, math learners, for our last part of the discussion, we have here rational numbers in the number line. Of course, since rational number is a number, it can also be located in the number line. We know that a number line is a line with numbers, but as what we have been recognized in the easier times, we all know that in the number line, we can just see the integers, meaning the 0, the positive numbers, and also the negative numbers. Now, how do we plot our rational numbers in a number line? Now, let's consider first 1/2. 1/2 is technically between or the half of 1, right? That is why 1 divided by 2 is 1/2. Okay, if you convert 1/2 into a decimal, this is 0.5. Now, in the number line, this is less than 1 but greater than 0. And this is positive, right? So, technically, 1/2 is just between 0 and 1. So, therefore, if this is 0 and 1, 1/2 is located here. Easy, right? Now, how about 5 over 2? Okay, 5 over 2, if we convert this one, this will become 2.5. Meaning that this is bigger than 2 but less than 3. Okay, so therefore, our 5 over 2 is located between, if this is 3, okay, therefore, our 2.5 or 5 over 2 is located between 2 and 3. Now, how about this one? We have negative 1/4. Negative 1/4 is basically a negative number, right? So, therefore, it is located in this side of the number line, before 0. However, 1/4 is not yet 1 whole, right? And 1/4 is 4 times smaller than 1 because 1/4 plus 1/4 plus 1/4 plus 1/4, that is 1. So this is the whole duration or the distance between 0 to negative 1. Since this is negative 1/4, so we will be talking about here. Now, 1/4 is 4 times less to our negative 1. So, we all know that 1/2 is between 0 and 1. So, therefore, negative 1/2 is between 0 and negative 1. So, we have here as negative 1/2. But we are talking about 1/4. Remember that 1/4 is half of 1/2. Okay? So, if this is your whole 1 unit, you just divide it into 4 parts. So, that is the first part, the second part, the third part, and the fourth part. Okay, so this is the whole part. This is first, second, third, and fourth. So therefore, our negative 1/4 is located here. Easy, right? So, let's wrap up our discussion for today. You already have known the definition of rational numbers. You already know the different forms of a rational number. You have known how to convert fractions to decimal and decimal to fractions. And now, you also know how to locate rational numbers in the number line. And now, this is the time that I will try to challenge you whether you have really understood our discussion for today. And here it is. Math learners, I hope you have learned a lot of things about rational numbers. This is still your free access math teacher, Ash. And by the way, I'd just like to give a shout out to these students. As well as, do not forget to subscribe, like, and share our videos. Thank you so much for your support. And always remember, it is fun to learn mathematics if we are together learning. Keep safe, God bless, and have a great day. Fellow math learners, if you think you like this video, hit the like button and the subscribe button. That is, if you are committed of learning mathematics the easy way. Thank you.